Okay, now in this section 4-2 we're looking at transformations of exponential functions. And so I've given you a little chart here that can show you how the graph is changed when the equation is changed. And so if you keep this in front of you, this can kind of help you to determine what the various translations would be. Alright, so let's kind of go through these and we'll illustrate it on the graph as we do it. So from the parent function, right? And remember the parent function is just the a to the x power, so some base. So here they've taken 2 to use as our base throughout the examples. And so let me just graph that. So we're going to graph 2 raised up to the x power. Okay? Alright, so there's the graph of 2 raised up to the x power. Now, if I were to take and add a number to the end of that, like for example plus 3, look at what happens. Alright, it shifts it up by 3 units, right? Or if I were to change that to a minus 6 like we have here, okay, so that's going to shift it down by 6 units. Okay, so that's the first type of movement, adding or subtracting to the very end. Okay, the next type of movement is by adding or subtracting to the exponent itself, right? And so let's see what happens if I just were to subtract. Oh, don't want to do that. Remember we ran into this last time. I actually have to put it in the parentheses, so let's do it. So that's going to be minus 2. And so look what happens. Okay, it has actually shifted 2 units to the right. So very similarly, when you subtract directly from the variable in most other functions, then it moves it 2 to the right. And if you were to add, of course, well, let's change this to plus 1 like they've got here in the figure, or on my chart I should say, plus 1. Alright, so it has moved the graph, shifted it 1 unit to the left. Shifted it 1 unit to the left. Okay? Alright, so adding or subtracting moves it right or left there, or directly to the exponent variable. Alright, now let's see what happens here. Suppose I were to multiply the entire function by a certain value. So let's say I go up here and I go 6 times this. Alright, so what happens is we have a vertical stretch. So we've stretched the graph out vertically, right, by a factor of 6. Stretched it out vertically by a factor of 6. Okay, so what about if I multiply by something that's less than 1, like say a 0.5? Alright, so 1/2 and 0.5 is the same thing. So I have now a vertical compression. I've compressed the graph, right? Compressed it by a factor of 1/2. Compression by a factor of 1/2. Alright? Let me see here. What else do we have? Next we go to horizontal stretch and compression. And so that's going to be obtained by multiplying by a number directly to my x. And so if I'm multiplying by something that's going to be less than 1, like a 0.2, like we have here, so that's a vertical horizontal stretch by a factor of 5. So you stretch that graph horizontally by a factor of 5. Okay. What about if I multiply it by something that's greater than 1, like say 3? Okay. Then that is going to be a horizontal compression by a factor of 1/3. Okay. You're compressing it by a factor of 1/3. Okay. All right. Let me see here. So the important thing to remember here is, like with a vertical stretch, okay, it's stretched or compressed by whatever factor that you are multiplying by. However, when you get to a horizontal stretch or compression, it's stretched by the reciprocal of the value that you're multiplying by. Because like here we multiplied by 1/5. Well, it was stretched by a factor of 5. It's stretched by 5 times. So don't forget, with horizontal compression or stretch, you need the reciprocal. Like here we multiplied it by 3. Well, it was compressed by a factor of 1/3. Compressed horizontally by a factor of 1/3. So keep that in mind with the horizontal stretching compression. Whatever you multiply, the factor is going to be the reciprocal of whatever that number is. Flip the fraction. Okay, we can also get a reflection out of this thing by either making the base negative, and that's flipped it across the x-axis as you were able to see there, or if I make the power, the x, the exponent here, if I can get it, there we go. If I make that negative, it's going to flip across the y-axis, as we can see right here. All right, so there you go. Those are all the different types of movements that you are going to have and the different types of transformations. And so now let's do some of the problems that we want to look at. All right, so what we want to do is we want to take this and we can verify it by the graph, or if you remember from your chart, you can do it that way as well. Like for example, if I were to take this one, 4 to the x power, and subtract 3 from the entire function, then I should remember that that's going to move it 3 down. If you didn't remember that and you can't see it from the chart, then graph it and see what happened. If I were to graph this first one, 4, and raise it up to the x power, all right? And then right below it, let's say we graph the new function, y equals 4 to the x power, double x power, don't want that, minus 3. Okay, so we can see that it indeed was pushed down by 3. Okay. All right, so what about the next one from here to here? So what happens? They've multiplied this, right? Okay, by a factor of -2. All right, so first of all, since they've multiplied this by a factor of a negative, right? Since they've multiplied this by a factor of a negative number, right? Then I know that's going to be reflected across the x-axis. Right? So first of all, that's the first movement. Okay, reflected across the x-axis. All right? And of course there's another movement. So since this is a value of 2, don't forget also what happens when you multiply it directly to the exponent there, right? Or to the base, I should say. You get yourself a vertical stretch or compression, and so since this number is greater than 1, it's going to be a vertical stretch. So this is going to be a vertical stretch, and that's going to be by a factor of 2. Vertical stretch by a factor of 2. So the negative causes the reflection, the multiplication by 2 causes the vertical stretch by that factor. Okay? All right. Next one. Okay, so this time I start with 2 to the x power, and that changes to 2 to the x power minus 2 and plus 5. Well, remember, minus 2 directly to it, right, is going to cause it to move to the right. So that'll be 2 to the right. Okay, 2 to the right. And adding 5 directly to the end of it is going to cause it to move 5 up. So once again, you can refer back to your chart if you don't remember that, and then you can also graph the two of them and see what happened to come up with the right answer as well if you don't remember. Okay? All right, last one we need to take a look at here is starting with 10 to the x power. Okay? And it changes to 10 to the negative x power plus 3. Alright, so when you see negative x power, then you're going to say, oh, reflect across the y-axis. Okay? And I would say that I agree with that. Reflect across the y-axis, good. Okay. And the next thing you're probably going to say is, oh, plus 3 to the x. So plus 3 to the x is going to move it to the left 3, right, guys? According to the chart. Let's see. Plus 3. Yeah, so 3 to the left. However, that's not correct. And if we want to verify that that's not correct, let's graph it. Alright, so I'm going to get rid of this one. And let's change this now. So we want to get a new function. Let's go 10 to the x. 10, raise it up. X power, got it right there. And let's get the next one. Y equals 10 raised up to the negative x plus 3. Alright. Okay, so when we're looking at this here, alright, first of all, when you think about this one, okay, it may look indeed like it is moving to the right, but here's the thing about it, okay? What you've got to remember is, okay, this thing will first move, right? It's first going to move right or left, and then it's going to be reflected, okay? And so the reflection part of this comes last, so I really should write that last, and that's what I'm going to do, just to make it a little bit easier for you. So when you get multiple things happening, okay, you really got to kind of think about, okay, what's going on here. All right, so when we think about this, okay, oh, I just messed that up, didn't I? Need to get that. Let's see. I need to put that in parentheses. We learned that before. Plus 3. Yeah. Okay, now we close it off. Alright, so that's a little better. Alright, so now when you look at this thing, okay, you should be thinking that, okay, so I thought this thing was supposed to move to the left, so what happened? Alright, or excuse me, I thought it was supposed to, yeah, with the plus 3, I thought it was supposed to move to the left. Well, it appears that it's actually moving over here to the right, doesn't it? Okay. And so when you think about this, okay, here's what I want you to remember. All right. The thing that we have to remember about this thing is when you're looking at this. Okay, so remember, plus 3 should be moving it to the left, right? So how come it's moving off to the right? Well, here's what we need to think about here. So first of all, yeah, oh, don't want that. All right. Here's what we need to think about here on this one. Okay. When you take a look at this, it's helpful to rewrite it like this. G of x equals to 10. Okay. And if I rewrite this power as negative, open parentheses, x minus 3, okay, we can actually see that minus 3 should be sending it over to the right hand side, okay, and then it's going to be flipping across, reflecting across the y-axis, right? And so that's kind of like the way that we need to think about this thing. And so when we're looking at it here, once again, now I can look at, oops, I can look at this movement, right, reflecting through the x-axis, and we can go ahead and write that. I know I erased it at first. Okay, so y-axis, all right, reflecting through the y-axis. And so then from there, when we look at it like this, after it reflects, okay, after it reflects, then it's going to be moving 3 spaces actually to the right instead of reflecting and then moving 3 spaces to the left. And what might also be helpful is to put it in here after the reflection is being made, right? So like if I put in y equals 10, and I raise that thing up to the, what, negative x power, right? All right, so you can see that here's the original, here's what it looks like after the reflection, and then from there it goes 1, 2, 3 to the right. Then from there it goes 3 to the right. Okay, so again, if you're looking only at this part of it, you might say, okay, it does the reflection, and then plus 3 directly to it, plus 3 directly to it. See, it should move it to the left, right? Well, it doesn't move to the left. It doesn't reflect and then move to the left. It reflects and then moves to the right. And this is the reason. Okay, so when you're looking at this, okay, this plus 3 is actually minus 3 once you factor that negative back out of there. All right, which is what needs to be done in order to see this happening. So be careful that when you're looking at this, you say, oh, it's reflect through the y-axis, and then it's oh, to the left by 3. Well, once you go in and you see that this is rewritten as this, negative the entire exponent, and then x minus 3 is the way it should be written in order to make sure that you're getting those movements correctly. And that's verified by the graph, as we see right here. Here's the original function, okay? And here's after the reflection, and then here's after the plus 3, which is moving it 3 to the right. Okay, so be careful there, because this is actually can be written as 10 to the negative, open parentheses, x minus 3. And so if you wanted to just verify, we could write this function this way and graph it on here and see if it's the exact same. And it will be. So it'll be y equals 10, raise. And so let's just raise it to a negative, open, x minus 3. Alright, and notice it dropped right on top of the other graph that we already had. So we know that these two are the same. Okay? And this is the form that we need to write it in order to get all of our movements. And so, of course, that second movement is going to be 3 to the right. All right, 3 to the right. Okay, so make sure that you keep that in mind. Okay, it can be kind of tricky because this is disguised when it's in this form. All right, so hopefully that helps you be aware of that particular situation when it's like that, when you've got negative exponent up here like this. Make sure you rewrite it in this form by factoring that negative out of there and putting this in a set of parentheses so you can actually see what the movement is. And when you're coming across problems like this, it's good to verify it, because as soon as you see the graph, you would say, hey, that didn't move to the left, it moved to the right. What happened? And then that will alert you to make sure that you recognize that this is the way that it should be rewritten. Okay? All right, very good. Now you can go and finish your quiz.